The rising cost of renting. Linear versus exponential model. Linear versus exponential models. You know, you try to be funny and it just never works. The housing market is overwhelming. Truth. Supply and demand are just one factor leading to increased prices. A new landlord is creating two options for rent increases over the next few years to be built into new rental agreements as shown in the table below. So we have option one, we have option two. First, let's look at option one. What type of growth pattern is this? I go from 9 to 975, which is an addition of $75. 975 to 1050, that's 75 more. 1050 to 1125, it's plus 75 more. We are adding a constant number, so this is linear. And if it's linear, that means my slope is 75 because that's the constant change. And we know at year 0, the initial, there's my y-intercept. So the mathematical model would be y equals slope times x plus 900, right? Rent is increasing $75 each year. That's what that says. Great, love this for us. Look at option 2. What kind of model is this? Well, hopefully you can see pretty clearly it is not linear. So we're going to check for exponential. So I'm going to take 967.5 and divide by 900. And that gives me something, 1.075. And then I go, okay, I'm going to take 1040.06 divided by 967.50, and I get roughly 1.075. Check them. Yep, that's what it is. So we have an exponential with a growth rate of 1.075. So the model is y equals the initial value of 900, growth rate of 1.075 raised to the x. This tells us the 1.075. If I subtract the initial 1, I get 0.075 as a decimal, multiplied by 100 to change it to a percent. That means we have a 7.5% increase in rent each year. That's what it tells us. 7.5% increase. Okay. Oh, based off that, let's finish the table. All right, so first I'm going to finish the table for linear, because that one's easy. I just add 75. So 1275, 1350. For, exponential, can't even talk anymore. Since we know the rate here, all we have to do is simply take the previous one and multiply by 1.075, because that's going to give us the next year. So that gives me $1,292.06. And then again, we multiply that by 1.075, and we get the last one of $1,388.96. Okay, now that we've finished our table, now we can move on. What comments can you make about the two plans at years 0 to 3? All right, so focus 0 to 3. Well, in year 0, they're the same. After that, greater, greater, greater. So for years 0, they are the same. And then for years 1 to 3, the linear option is more than the exponential option. So for the first 3 years, you'll pay more if you have option 1. But in years 4 to 6, notice, that's a bad color, notice that the exponential is more. So in years 4 to 6, the exponential is more than linear. So what can you make about this? If you are looking at this, this rental agreement and you have these options, you can say, well, I know that I'm only here for grad school. That means I'm going to be here for 2 years. I should go linear, right? So if you're looking short term, just one, 2, or 3 years, you want to go linear. If you're like, you know what, I love the location, I love what I'm doing, I love all the things, I'm going to be here forever. I just lied. Back up, back up, back up. I'm glad I caught that. If you're short term, you want to choose exponential. Oh my gosh, you guys, I almost led you astray there. Short term, you want to go cheaper, right? So you want to go exponential because it will be cheaper in the short term. So for 0 to 3 years, 1 to 3 years, you want to be in the short term. Long term, if you love where you are, you love how this works, you want to be here and live here forever, then you want to do linear because over time, it will be cheaper with the linear. Short-term exponential. I'm sorry that I messed that up, but generally we talk about money and you usually want more later, which is kind of crazy. Okay, anyway, that's a little bit of the cost of rising with linear versus exponential models.